And we are good to go.
All right. Question number 3. The true linear regression equation is y equals, what is that, beta, right? Beta 0 plus beta 1 x, where beta 0 and beta 1 are unknown. What are the null and alternative hypotheses for beta 1? It would be C.
Yep.
Beta 0 and beta does not equal 0.
Yeah.
Question 4, residual. I would say C is the difference between the observed value y and the value predicted by the regression line.
Just due to the formula, right? Which is y minus the
y equals beta 0 minus beta 1 epsilon, or is it epsilon? No, the E.
Epsilon.
Is it epsilon? Yeah,
Yep.
the Greek E. I don't know.
Greek E.
Okay. A plot of residual supports using linear regression when I'm going to say A on that one, right? Am I thinking this backwards?
Yeah, I would say A because, well, we talked about linear regression, but then they also talked about scatter the QQ plots, and if they're in a line, then it's like they're not. I don't know, that one twisted my mind because one of them is if it's in a line, then it's normally, and if it's not in a line, then for the other one, when it is in a line, that means that they are not like related at all. So I didn't really understand that.
Yeah, it says in the reading that if the points in the QQ are close to the line, we can just conclude that they're normally distributed.
3.4, right?
Yeah.
Yeah, I'm reading the same thing.
The next 8 problems, we're going to use the data found in math self-sufficiency.
Okay, math self-sufficiency.
And we're going to use, it doesn't state which one's going to be which, so I just assume we're going to copy and paste it.
Well, you have to find which one is the cause and effect. Does that make sense? But it doesn't really help because there's a score and confidence rating mean. I would say that confidence rating mean goes in the variable X. Because they did a test. They did a test. I don't know if you guys remember this last time, where it said that those that were more confident in the test scored higher, and so I'd say that the score is the response variable.
Okay,
that works. The other question is, does gender affect anything or no? I'm assuming not, but I just want to make sure.
I don't think we've done multiple. We've only done up to 2 so far.
That's cool. I just figured I'd ask because I noticed I got the different genders in there too. So.
Okay, let's see. Compute the residuals for the data using software. What statements best describe the residuals?
So hold on, I'm going to try putting them in a score as X real quick as well, just to see what the difference is. Ugh, they both look right.
What do you mean they both look right?
So they both basically pass the tests.
Well, I would say based on what I'm getting that the residuals follow a linear pattern. Just
Yeah.
because they're kind of in a very fat hot dog.
Yeah, I'm seeing that.
Because, yeah, I don't get any value that's lower than 40, and if they were negative, then they'd be slanted the other way around.
That's true.
Same. So B.
B.
Yeah. So based on the QQ for these residuals, what can you say about these residuals? This is a weird one. I'd say fairly normal, but
let me plug that into the QQs here.
Oh yeah, I should do that. I'm just looking at the ones that are here.
Well, I'm kind of. Oh, so I got a question now. So this plot that it looks like a QQ plot that pops up in the linear regression, is that the QQ plot for the residuals, or is that just from the data that we inputted?
I think it's supposed to be for the residuals.
Okay. So residuals are clearly not normal, fairly normal. They look right skewed. I would say fairly normal. Yeah.
Okay. It's just hard. I mean, I don't know, unless there's like boundaries or I don't know.
Yeah. There's a lot of like unexplained things with this testing, and that's why I don't like it, because I don't understand it. I just plug and chug kind of a thing. And
they're just telling you what to do, not how to do it or why to do it.
Yeah. So I feel like I'm going to get tripped on that. All right, question 8. Use software to create a scatter plot for the data, given the scatter plot, residuals plot, and the QQ plot. Scatter plot, residuals plot, and the QQ plot makes it sound like there are 3 different things. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply.
All right, so the first one, that there's a linear relationship between X and Y. That is true, right?
Well, I'm trying to remember, because there was one of these instructional things where it like you had to make a separate I think it was the scatter plots. I'm trying to find it.
Wasn't that what this is right here on the linear regression thing? Isn't that a scatter plot?
Well, it might be a scatter plot, but I'm also thinking that that is the residual because
the only reason I don't think it's a residual plot, because if you look at the residuals, it goes into the negatives, and nothing on here goes into the negatives.
Good. Well, then I'm not really sure what the heck, because having 3 of the same kind of testing with different results and they're all plots, I'm not sure what purpose they all serve if they're supposed to be different.
Yeah, I'm going through the reading again, seeing if I can find anything.
So scatter plot. Okay, so if the scatter plot is a hot dog shaped, then that means that X and Y have a linear relationship. So that makes sense.
Right. Well, that would be this graph that we use here that's on the page. And then we need a residual plot. See, when they did the residual plot in the video, it had negatives too. So that's why I feel like we're almost missing a page in this document.
Yeah, I can see that.
Because we don't have the residual plot. We don't have a place with the little ANOVA thing. Like, I feel like we're just missing.
So it says that column E. Okay, check this out. So in the Excel instructions, I knew I read about this, for residual plots, right? The residual is on the linear regression tab in column E. So those are the residuals. So we have to make a residual plot based on that. So basically you highlight all of that and you make
our own.
Yeah, and then you make a scatter plot of that.
I've done that, and it doesn't have the whatever they call megaphone shape is what they kept saying. Is that what it was in the video?
No idea.
Yeah.
Well, the megaphone is for the constant variance in the residual plot. Yes.
So
I'm assuming we're just making is it a scatter plot of the residuals?
Yeah.
yes. And then it says that if they show random scatter, then or there's no obvious pattern. Okay, so it says if linear regression is appropriate, meaning that there is linear regression, then the residual plot, the one that we just made based off the residuals, will show no pattern and will consist of random scatter. I'm showing random scatter, but it's kind of just like a line across my chart.
Yeah, here I'll show you what I have. You guys can see if yours is similar. So that's what I got from my residual.
The second one.
Yeah.
Okay.
Mine's messed up. Hold on, because I made it with the tutorial, and so it's only using a select amount of the information, not the entire column. Wow.
Yeah.
Okay. Maybe that's too much information.
Yeah, if you do the control shift down, it goes all the way down to the bottom because they put the little bars around them.
Yeah. So because there's a formula, it all comes out as 0. So there's a bunch of zeros. There we go.
Yeah, so if there's random scatter, that just means that there's linear regression. Is that correct?
Yeah.
Okay. The residuals are normally distributed. So that's C. Okay, where's that table? There's a cheat table here. Okay, so how to check linear regression, scatter plot, and residual plot. We just checked those. Normal error term is QQ plot of the residuals. Points in the QQ plot are close to the line. Was the QQ plot in like a linear pattern?
So were you guys able to just copy the residuals over to the QQ plot or no?
No, not this time. When I was going through the homework, I could, but this time it's like it's only adding the formula.
Yeah. Okay. That's what I'm getting to, and it just says error.
Yeah. Let me see.
Because I'm not going in and typing 139 different.
Nobody blames you.
Are you separating the male and female, or sorry, the two responses, or are you just adding them all together in the?
I just did the residuals, but because the residual is a formula, when you copy it over, it's not going to accept it.
So right click and paste special
with the formulas.
Yeah. So in the QQ plot, well, that didn't change the QQ plot at all. Hold on, let me try that again.
Just place the value.
Yeah, but that didn't affect the actual QQ plot.
I got it. I just right clicked and did the numbers only.
Yeah.
And that Q plot does not look pretty at all.
Well, you have to order them from greatest to smallest. Otherwise, they will be scattered.
Wait, you said-
small.
I got
You said-
linear.
Oh yeah, mine's like right on the line.
Yeah. So that one checks out.
Okay.
And that's for C, right?
No, C is the one that we just did, the residual plot, like that.
Oh, okay. Yeah.
This one is let's see, I have the tests up. Normal error term. So I would
Is that the B?
constant variance residual plot, no megaphone shaped in the residuals. X's are known constants. So that's something else. Observers are independent, cannot be checked directly. So according to the requirements, variance of the error is constant for all X values. I'm not sure how to check that one. X values are measured without error. We can't check those. They're just given to us. So I would assume that that one's met. And then the observations are independent. We don't really know because we didn't gather the observations. I would just assume it is. So, but I don't know how to check the variance of the error unless the table has something about that. Let me see here. Oh, variance.
So it talks about how in the residual plot it shows random scatter. There's no obvious pattern. There are several patterns that could arise, one of them being the megaphone. If a megaphone shape occurs when the points tend to be close together, one side and far apart on the other, it suggests that the variance of the error terms is not constant for all values of X.
Okay, but since we didn't get a megaphone, then
right. So in this case, the variance of the error term is constant for X.
Okay, so all 5 of them are.
It sounds like all 5 of them are true.
Okay, what is okay? Gotta go back to my graphs and stuff here. Okay. Okay. What is beta 1 and estimate the estimate for the slope? I got 12.695.
Same.
12 Wait, for the slope? Hold on. Oh yeah, 12.695. Yeah. Real quick. So sorry, on the last one, what all did you guys wind up clicking? Because I can't.
All 5.
All 5.
All 5? Okay.
Number 10, the lower bound, I got 10.674. And the upper bound of 14.715.
So sorry, 10.674. I'm cutting out pretty. Either you guys are cutting out. One of us is cutting out. And
lower bound, I got 10.674. Upper bound, 14.715.
Okay, awesome. Same.
Based on the evidence using the level of significance alpha equals 0.05, what decision would you make regarding the hypothesis test for beta 1? Well, my p-value that I'm getting here is really, really small. And so we fail to reject, we reject the null hypothesis, which means that they aren't equal.
Yeah, so that's going to be C, right?
Yep. That's what I got.
Okay.
For question 13, for a hypothesis test for beta 1, the slope, if you reject the null hypothesis, what does it mean? So if you reject the null hypothesis, it means there's sufficient evidence to conclude that it's not 0, right? So it would be D.
If you reject the null hypothesis, what does it mean? There would have, what did you say, B?
D.
D?
Because the null hypothesis is that it equals 0, and the alternative is that it does not equal 0.
Correct.
Oh, I see.
So if you reject the null, it means that there's sufficient evidence to conclude that it's not 0.
Correct. Yep.
Yeah.
Right. And then
switching to new stuff.
Crocodile. Fun.
Hey, at least they didn't ask us to watch a video this time.
Did you guys watch that whole video?
No.
Oh, I did. And then at the end, I'm like, this had nothing to do with it. I did not have to watch that. It was interesting. Like, it was cool that they could determine what the estimated size was based off of that. But
Size.
yeah, I'm like, I've got so much other homework. I wish I didn't watch that.
I got so much other stuff to worry about that's not my free time video I want to watch.
Fair enough.
All right, so for this data, which variable is the dependent? Isn't that body length?
The dependent, yeah, the dependent is the body length. So that you can just copy and paste them as they are, which makes it nice. All right, for this data, which variable is dependent? Yeah, body length. Now construct a 95 constant interval for beta 1 and put your answers to the margin of error, lower bound, and upper bound. Let's see. Sorry, that. So
For be the
margin of error would just be the two intervals divided by 2, right?
Yeah. So the high minus the low divided by 2. I got 0.442.
.443 is what I got, just because the fourth digit's a 5.
Oh, see, mine's a 4.
Okay, so then 0.442. Let's do that.
Well, Matt, what'd you get?
Hold on.
Well, I'm using my cell phone to do these calculations.
0.442.
Yeah, that's what I got.
Okay.
And lower bounds, I got 7.218.
Yeah.
Upper is 8.103.
Yep.
Okay, question 18. Based on your lower bound and upper bound from the last two problems, what can you say about beta 1? Oh, man. Question failed. The confidence interval will contain the true value B. Yeah, it's A.
Let's try this. Let's see how. It's interesting. We went through that whole thing, and they didn't mention the ANOVA thing once, like the degrees of freedom or anything related to the reading at all.
They just threw it in there to like see who was paying attention, to see who would post it on the board.
We missed 2.
Which ones did we miss?
Question 8, where we marked all of them, and then question 6, where we said that they form a linear pattern.
Okay.
So so that's why. So question 6, we were looking at the
plot, not the residual.
Yeah, not the residual. So the answer for that one would be between -40 and 25, because I'm looking back at it now.
Yeah.
So that one would have been A. And then question 8, I don't know.
Yeah, because it doesn't really tell us what we got right. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by the step? 5 assumptions. Yeah, I'm going to have to look into that. Scatter plot, residual plot, and the QQ plot. So if you get a scatter plot and it has no pattern, that means that there's a linear relationship, right?
Right.
And then if you have a residual plot and they're in a hot dog shape, that means that they're normally distributed, right?
Correct.
And then if there's a QQ plot and it's close to it, that means that the variance of all x values is constant.
Correct. So the first 3 we know are.
So,
correct.
But we don't know about the observations being independent or x values are measured without error. I don't really know. I don't remember reading about how to figure that one out. The x values are measured without error. Let's see.
If you guys want, I can talk to my sister about this one and answer all these questions.
Yeah, that one would be helpful just because, like, it doesn't tell you what you got wrong or, like.
Yeah.
Slap in the face.
And is she going to be available while we take our exam together, right? Just kidding.
She might be.
Like